Alrighty, so today we're going to be having a look at the root form of the quadratic. And I guess the real question about it is that what is a root and where is it coming from? So to find the y-intercept, right, we set x equal to 0. Well, that's quite easy in this form to figure out what the y-intercept is, because we're just substituting x equals 0 in and solving for y. That's relatively straightforward. The more complex one is actually finding the x-intercept. Now, in quadratics and in polynomials in general, we often call these roots. And these occur when y is equal to 0, which means we end up with the equation 0 is equal to ax squared plus bx plus c, which we know how to solve from null factor law if it was something times something, but this is not that. We have got three separate terms here, so null factor law cannot help us. But what if we could write this as a something along these lines? Well, if we could do that, then this would be quickly factorized and we'd be able to see the roots. From just as our knowledge, when we're thinking about a quadratic, we're thinking of some kind of shape like this, which could have two roots, or it could have, oh, that didn't quite go low enough, it could have one root, or in fact, it could very much have no roots at all. So there are many different options, but with the root form, what it says is that if you do have two roots, then you can quickly write the function, well, this is b comma 0, and this is c comma 0. You can quickly write it as y is equal to a, some constant, x minus b, the first root, x minus c, the second root. So root form is a really powerful thing, because if you can write your equation as y equals a, x minus b, x minus c, you by default know that b and c both have to be roots of the function. So let's actually have a go at trying to sketch it. So we got y is equal to 3, x minus 2, x plus 4. Okay, so let's have a look at this one. So first of all, we can say that the y-intercept is when x equals 0. You can go y is equal to 3, 0 minus 2, 0 plus 4, which is 3 times negative 2, negative 6 times 4, negative 24. So therefore, our y-intercept is at 0, negative 24. And then we can say, well, when's the x-intercept? Well, the x-intercept is when y equals 0. Well, when this is the case, we can use null factor law. This can only be true when x minus 2 is equal to 0, or x is equal to 2, or if x plus 4 is equal to 0, or x is equal to negative 4. Now, some of you might be going, well, what if 3 is equal to 0? Which is absolutely true, except 3 can never be equal to 0, so we never use constants in that way. So we've got two roots here. And so we've got our 2 points here, 2, 0, and negative 4, 0. And now we can actually sketch this graph pretty happily. Now we know it's going to be concave up because of the fact it's got a positive a term. So now we just need to do a quick sketch. So we're going to get 2, negative 4, and then our y-axis is going to be quite steep. Going to have maybe 5, 10, 15, 20, 25. So 24 is about here. And we can quickly see we're going to end up with some picture like this. Okay? And there's our equation. Y is equal to 3 x minus 2, x minus x plus 4. Alrighty, so there we go. Our sketch is done. Don't need to do any more work than that. Finish up my axes, my labeling. But the more interesting thing is to say, well, what else do we know about it? Well, I said before, it's concave up. We know all of the intercepts. We've got one y-intercept, two x-intercepts. We've already sketched those on. But the one thing we haven't talked about is the axis of symmetry, or the turning point. So the axis of symmetry, well, remember, it's a symmetric function. So it's going to occur halfway in between -4 and 2, meaning since -4 and 2 are our two roots, we can write that in general as b plus c over 2, which in this particular case, so it's x equals b plus c over 2, b plus c, well, in this case it's -4 plus 2 over 2, which is -2 over 2, which is -1, which indeed matches our quick sketch that we did. So the axis of symmetry is x equals -1, which also means that the turning point, well, we already know the x-coordinate. The x-coordinate is -1. So the y-coordinate is going to be whatever the function is evaluated at x equals -1. So sub x equals -1 into the equation. Alrighty, so we get 3 times -3 times 3. 3 times 3 times 3 is 27, with a minus at the front, so minus 27. So our turning point is going to be -1, -27, which we can put on the graph like that. -1, -27. Alrighty, so there's a little bit of playing around with our function. We'll do domain and range. Domain, as per the usual for a quadratic, x is in the real numbers, and the range, it's got to be bigger than -1. So y greater than or equal to -1, or y is in -1 up to infinity. Alrighty, so that's how you can quickly sketch a turning point version, a root equation quadratic. If you end up with a quadratic that isn't in root form, well, hey, better factorize it first. Alrighty, I'll see you on the next one. Goodbye.